This is the last video for a time period. Here is electrolysis through induction through the air. There's the cell that we'll be looking at. That's a smaller cell than what we used before, and we did put a little bit of a electrolyte in there. That spoon above there, it's the amount of electrolyte we put into the glass. Now we want to quickly go through the parameters of what's going on. First, we're going to look on the input as usual. We got an input of 113 volts, enabling 5.6 amps through the lines. And now we've made a difference. What we've done now is we put both of the lower 14 gauge coils on the high induction coils, and they're both contributing. But then again, we're looking there. The back one, we got 5.56 amps in. We got 613 going into that back coil over an induction coil, and we also got a front one. On the front one, we have 6.83 amps going into the front coil, and we got 9.9 DC pulse amps going into the regular cell at a voltage of 23 pulse DC volts, and 11 amps going into the rectification system. That is the primary thing there. And then there's the primary action of that cell. It was producing electrolysis of distilled water. Now quickly we want to go back and look at the secondary action. Some of the energy that has been retrieved through the air. Now we have the adjustment meters. Should have had this done but didn't. We got 40 milliamps going through the tighter coupled coil, and we got 25 milliamps going to the second one, and then we got almost 25 milliamps also going to a different source, and here we'll show the different source. Out of that, we're taking 396 volts acquired through the air, and that's going down into our step down transformer, and after it's stepped down, it's becoming 6.5 volts, and that 6.5 volts is what is doing the action on the smaller cell. As we can see, the smaller cell does have some electrolytic action. We do have a little bit of electrolyte in that cell, and that should be about it for showing that some of the power can be retrieved through the air through the high induction coils on the resonant current ballasting of the main electrolytic cell. See if I can get a close-up of that cell action. Well, that's pretty appreciable cell action, I would suppose, since it's entirely coming through the air. Well, I think you covered everything there. Now, once again, there's the secondary action. 20,000 ohm induction coils, impedance-wise. And we assume that 25 milliamps there, via the shorted plug, all the outputs are achieved by connecting that across the neon, thereby preventing the neon from lighting. And then again, electrolysis through the air. Ha ha! It works. Not a good thing, but it can be done. Thank you.